Alright, in this video we're going to talk about cameras. This picture right here from the textbook, this is on page 146, gives you the coordinate system and the vectors used to specify the camera. So this vector G is the gaze direction. This is the direction that the camera is looking. And this point E is the location, or the eye location of the camera. The other thing that the user gives you to specify the camera is this vector T, which points in the direction up. Now keep in mind that the vector T and the vector G don't necessarily have to be perpendicular or orthogonal. The vector T just says up is in this direction relative to the gaze vector. That wasn't a great way to say it. What the vector T does is the vector T and the vector G define a plane, and the real up vector of the camera, which is perpendicular to G, lies in the same plane as G and T. We'll talk about that in a minute maybe. These other three vectors, U, V, and W, these three vectors are the coordinate system for the camera. The thing about these three vectors is each vector is perpendicular to each of the other three vectors. So U is perpendicular to V, V is perpendicular to W, W is perpendicular to U. These three vectors are the coordinate system for the camera, and the vector V lies in the same plane as G and T. The other thing to notice is that the vector W points in the opposite direction of the gaze. We could have set it up so that the vector W pointed in the same direction as the gaze, but we didn't. It was just involved putting a negative sign when we take the cross product to form the coordinate system. These equations right here are the ones that you're used to build the coordinate system. So the input is G, which is the gaze direction, and then the other input would be E, which is the eye position. Keep in mind that E is not used to build the coordinate system. E is just the anchor for the location of the coordinate system. And finally, the vector T is used to build the coordinate system for the camera. So the inputs are G and T, the outputs are W, U, and V. This little negative sign right here is where W becomes the opposite of the gaze direction. This is a vector cross product. If you take the cross product of two vectors, then you get a vector which is perpendicular to both vectors and whose length is proportional to the area between the parallelogram defined, the area of the parallelogram defined by these two vectors. Dividing by the length of G normalizes the length of G, that is, makes the length of G 1. Dividing by the length of the cross product normalizes the length of U, and that is, it makes the length of U 1. So then finally, to get V, we take W cross U. You'll notice we don't divide by the length of W cross U. That's because W has unit length, U has unit length, so the cross product has unit length as well. So W is the opposite of the gaze, U is a vector which is perpendicular to W and T, and then V is a vector which is perpendicular to U and W.